High in the Chilean Andes, perched on the summit of a mountain called Cerro Pachon, stands a telescope unlike anything humanity has ever built. This is the Vera C Rubin Observatory, and housed inside its dome is the most powerful digital eye ever created, the LSST camera, capable of capturing images with a staggering resolution of 3.2 billion pixels. But here's what makes this camera truly revolutionary. It doesn't just photograph the stars as they appear in a single frozen moment. It records how the sky changes, second by second, night after night, watching the universe as it moves and evolves in real time. In just a few seconds, this telescope can swivel to a completely new target, scanning the heavens like some kind of cosmic security camera that never blinks. Each photograph it takes reveals millions of galaxies, countless stars, and faint traces of distant worlds that human eyes could never hope to see on their own. The fundamental idea behind this observatory is beautifully simple, yet absolutely revolutionary. Photograph the entire visible sky every few nights, then compare each new set of images with the ones that came before any object that moves, brightens, dims, or suddenly appears will be spotted instantly. From massive supernova explosions in distant galaxies to small asteroids drifting uncomfortably close to Earth, this project marks the beginning of a completely new era in astronomy. For the first time in human history, we'll be watching the universe in motion, not as a static postcard frozen in time, but as something alive and constantly changing. Every single image captured by this telescope is like a heartbeat of the cosmos, and when you put them all together, they tell the story of how our universe evolves, moment by moment, across the vast expanse of space and time. Don't forget to subscribe and like our videos for more content. The Vera C Rubin Observatory didn't just appear overnight. Its story stretches back more than 20 years, beginning when scientists first dreamed of building a machine capable of observing the entire sky with absolutely unmatched clarity. The goal sounded straightforward enough: capture the universe in motion, from the nearest asteroid in our own solar system, all the way out to the most distant galaxies at the edge of observable space. But making that dream a reality, that was an engineering challenge of absolutely epic proportions. The LSST camera alone took over a decade to design and carefully assemble. Its massive lenses measure 1.57 meters across, the largest optical lenses ever manufactured for astronomy. Every single component, from the sophisticated cooling system to the ultra-sensitive light sensors, had to be crafted with micrometer precision. Even the tiniest vibration could blur the incredibly fine cosmic details. This instrument was specifically designed to reveal. Teams from all around the world came together to make this happen. Physicists, engineers, computer scientists, and countless others, all contributing their expertise to create this singular instrument. At the heart of the system lies an ingenious three-mirror design, engineered to collect as much light as physically possible and focus it onto a detector roughly the size of a dining room table. When the completed camera was finally mounted onto the Simone Survey telescope, it represented not just advanced technology, but decades of international collaboration, persistence, and an unwavering commitment to pushing the boundaries of what we can see now. After all those years of planning and construction, it's finally ready to do what no other telescope in existence can do: capture the constantly changing sky in real time, creating a living record of the universe as it unfolds. Try to imagine a camera so incredibly powerful that it could photograph an entire cluster of galaxies in a single exposure. That's exactly what the LSST camera can do. With its 3.2 billion pixels, this is the largest digital camera ever constructed for astronomy, or for any purpose, really. Each image it captures contains so much detail that you could theoretically spot a golf ball sitting on the ground from 25 kilometers away. Think about that for a moment. The camera's detector consists of 189 individual sensors, each one carefully aligned and positioned to form one massive photographic mosaic. Working together, these sensors can collect light from objects that are literally 1,000,000 times fainter than anything the human eye could possibly perceive, even on the clearest, darkest night. To achieve this incredible sensitivity, the camera operates at temperatures colder than dry ice. This extreme cooling is necessary to keep electronic noise to an absolute minimum. Because when you're trying to detect the faintest whispers of light from the edge of the universe, even a single stray photon can make a difference. Every single exposure covers 9.6 square degrees of sky. To put that in perspective, that's about 40 times the apparent area of the full moon as we see it from Earth. In practical terms, that means in just one night of observation, the LSST camera can capture images of tens of thousands of individual galaxies, nebulae, and distant stars. And when all these images are combined over weeks, months, and years, they create something remarkable, a living, breathing record of the universe's history unfolding before our eyes. This isn't just a telescope in the traditional sense. It's a cosmic time machine continuously watching the past, present, and future unfold, one breathtaking snapshot at a time. Every night, as the sun disappears behind the peaks of the Andes, the Vera C. Rubin Observatory comes alive. The telescope begins its nightly routine, methodically scanning the heavens from one horizon to the other, photographing everything it can see. Within just a few seconds, it can shift to a completely new target, take a 30-second exposure, and smoothly move on to the next observation. By the time dawn breaks over the mountains, it will have photographed tens of thousands of square degrees of sky. This incredible speed and efficiency is what truly sets the LSST apart from every other telescope currently operating. It doesn't spend hours staring at one tiny patch of stars, gathering every possible photon from a single distant galaxy. Instead, it monitors everything simultaneously, creating a comprehensive picture of the entire sky. Every few nights, the telescope re-images the entire visible sky, then immediately compares each brand new frame with the previous observations of that same region. Any difference, no matter how subtle, signals that something has changed somewhere in the universe. A barely perceptible flicker, a new dot of light that wasn't there before a star that's suddenly started to fade. Each one tells a story. This technique, on which astronomers call difference imaging, allows scientists to catch transient cosmic events at the exact moment they happen. A massive star exploding as a supernova, releasing more energy in a few seconds than our sun will produce in its entire lifetime. An asteroid we've never seen before, drifting silently closer to Earth. Even incredibly subtle shifts in the brightness of galaxies that are billions of light years away. It's as if the universe has finally gotten its own security system, one that never sleeps, never blinks, and never ever misses a single cosmic event worth noting. Each night the observatory operates, the LSST camera produces an absolutely staggering ocean of data. Roughly 20 terabytes of raw images and measurements. To put that in perspective, that's the equivalent of streaming nearly 4,000 full-length movies in high definition, every single night. All of this data flows immediately to massive computer clusters, where sophisticated algorithms begin the enormous task of processing, sorting, and identifying what's genuinely new in the sky and what's already been cataloged. Over the course of its planned 10-year mission, the Vera C. Rubin Observatory will collect more than 60 petabytes of data. That's 60 million gigabytes, a digital record of the universe unlike anything that's ever been created in human history. But here's something remarkable: that this treasure trove of cosmic information won't be locked away, accessible only to a small elite group of professional astronomers. The data will be made freely available to the public. Scientists, students, amateur astronomers, and anyone curious enough to explore the cosmos will have access to this incredible resource. By comparing images taken days, months, or even years apart, researchers can track how entire galaxies evolve over time, observe how stars are born and eventually die, and follow how matter moves through the vast emptiness of space. These observed changes reveal crucial clues about some of the universe's deepest mysteries. Dark matter, the invisible substance that shapes the large-scale structure of everything we see, and dark energy, the mysterious force that's somehow driving the universe's expansion to accelerate faster and faster. Every single bit of data carries with it a story written in light, distance, and the passage of unimaginable spans of time. And together, these millions of stories will fundamentally rewrite what we think we know about the universe and our place within it. The Vera C. Rubin Observatory isn't just keeping tabs on objects we already know about. It's specifically designed to uncover things we've never seen before, things we didn't even know existed until they suddenly appeared in one of its photographs. Every new image holds genuine potential for discovery. A comet silently entering the inner solar system for the very first time. A supernova suddenly lighting up a galaxy that appeared perfectly stable just days before. An asteroid on a trajectory that might, just might, bring it dangerously close to Earth. Astronomers expect this ongoing sky survey to discover millions of previously unknown objects. The current estimates suggest the observatory will find something like 5 million asteroids we've never cataloged before. Tens of thousands of supernova explosions, and entirely new classes of variable stars that don't fit any category we currently recognize. For a planetary defense protecting Earth from potential asteroid impacts, this represents an absolute game changer. By tracking even the smallest movements of nearby space rocks over time, scientists can predict possible threats decades or even centuries before they could pose any real danger to our planet. But honestly, the most exciting discoveries will probably be the complete surprises, phenomena that don't fit neatly into any existing theory or explanation. Unusual cosmic flares that appear and vanish without warning, mysterious moving lights that don't behave like anything we've seen before. Events that fundamentally defy our current understanding and force us to completely rethink how the universe actually works. In many ways, the Rubin Observatory isn't just expanding our view of the cosmos, it's expanding the very boundaries of our imagination about what's possible out there in the darkness. Every single night, the LSST camera captures 20 terabytes of data, the digital equivalent of thousands upon thousands of Blu-ray discs. Over 10 full years of operation, that will add up to 60 petabytes. It's a cosmic library unlike anything that's ever existed before. This absolutely massive flood of information gets processed in real time by powerful supercomputers located both in Chile and in the United States. Sophisticated algorithms instantly compare every new image with all the previous observations, searching for even the tiniest differences. Faint flashes of light, objects that have moved slightly, subtle shifts in brightness that might signal something important happening. When the system detects something that's changed, it sends out an alert within just 60 seconds. That means astronomers anywhere on Earth can immediately point their own telescopes toward that location to study the event in detail before it fades away or moves on. But here's the thing. The sheer scale of this data is genuinely beyond what humans can handle alone. We're talking about processing and analyzing billions of individual data points every single night for a decade. No team of astronomers, no matter how large or dedicated, could possibly keep up. That's where artificial intelligence becomes absolutely crucial. Machine learning algorithms will search for patterns that human eyes and minds simply couldn't spot. Connecting millions of individual points of light into coherent stories about how galaxies form and evolve, how stars explode, and how time itself shapes the cosmos. The Vera C. Rubin Observatory isn't just passively observing the sky anymore. In a very real sense, it's teaching machines how to truly understand the universe, and that might be one of its most profound legacies. When the Vera C. Rubin Observatory begins its full-scale sky survey, astronomy will genuinely enter a completely new age of discovery. Every 3 nights, this remarkable telescope will complete a full panoramic scan of the entire southern sky, capturing billions of stars, countless galaxies, and millions of asteroids, all in motion, all telling their own stories. It will function like an enormous cosmic time-lapse camera, revealing how the universe evolves and changes, moment by moment, across scales of space and time that are almost impossible for human minds to truly grasp. Scientists are expecting Rubin's decade of data to reveal millions of asteroids we've never seen before, thousands of spectacular supernova explosions, and never-before-observed gravitational lensing events that will expose the hidden architecture of dark matter throughout the universe. The observatory's observations will also dramatically sharpen our understanding of dark energy. That completely invisible force that's somehow causing the universe's expansion to accelerate faster and faster for reasons we don't yet fully comprehend. But beyond all the individual scientific discoveries and advances, Rubin's mission carries a deeper, almost philosophical significance. For the first time in all of human history, we'll have a continuous, comprehensive record of our universe in motion. A dynamic, living portrait of absolutely everything above us. Each individual pixel captured by the LSST camera represents just one tiny fragment of that vast, living cosmos. But when you bring them all together, billions and billions of pixels, forming trillions of connections and revealing patterns we can barely imagine, they might finally show us what this universe of ours is truly made of, where it came from, and perhaps even where it's heading. The universe has always been in motion. Now finally, we're ready to watch.